Welcome to an example in which we're being asked to find all the zeros of this function right here. And they're telling us that one of the x-intercepts is 3. X-intercept is the same as 0. Those are synonymous words. So in other words, what they're saying is take this function, find all the x-intercepts, or find all the zeros, same thing. Find all the places that function hits 0. By the way, there's the answers already. But how do we find this? Well, let me show you. So one thing I'm going to do is I'm going to first show you this thing graphed on desmos.com. Let me show you that. So here it is. Here is, I went ahead and graphed it already for you. So there's our function, same function, right? 9x cubed minus 33x squared plus 21x minus 9. There it is graphed on desmos.com, graphing system. And you can see it, if I move it a little bit like this, it only hits the x-axis one time, doesn't it? See, and where does it hit? Right there at 3, like they told us. It only hits the x-axis at 3. So then what are the other zeros? Well, we call them zeros, but they're actually going to be imaginary. As you saw, they have eyes in them because they're not real. That doesn't really hit the x-axis anywhere else. It only hits the x-axis at 3. The other, what we call zeros, are imaginary zeros, but we still need to find them using our techniques. So that's what we're going to find. So let's go to it. All right, so there's our function. There it is, like I said. So 3 is the one real place it hits the x-axis, the only x-intercept, 0. The other two, this one and this one, separated by commas, they're both imaginary. They both have an I part to them, don't they? They're imaginary. They're not real. Doesn't really hit the x-axis at those places, but those are still valuable for all kinds of real-life engineering and chemistry and physics and stuff in the real world. So it's valuable and important that we find them, even though they're not real places it hits the x-axis. They're what we call imaginary zeros. And there's fancy stuff they do with electrical engineering with this and on and on. I'll let you find those things later. So let's go about it. How do we do it? So here's the notes. The notes say that you've got to take your original function and then you do synthetic division with the 1 0 they're giving you. Put it out here, do synthetic division, get your answer, and then take that and use the quadratic formula on it. So that's what I'm going to do. So I'm going to go in here and go, okay. And so just to give you an analogy, it's a lot like if I said, hey, I've got the number 30, and I'm going to tell you that 5 is a factor. It's one of the things that goes in. I want you to find the other things. What would you do? You'd go, okay, well, that's easy enough. I'll just go 5 into 30, goes in there, long divide, right? Goes in there 6 times. Remainder 0, of course. And so that means that 30 breaks down to 5 times 6. They gave me the 5. The 5's done. Then you'd have to, now you have the 6, break that down, 2 times 3, and now I've got the 3 things that go in the 30, 5, 2, 3. That's exactly what we're going to do, except we're going to do it with x's. So we're going to start with the original, that's this, and then we're going to take the thing they gave us, the 3, the x-intercept of 3, like if I gave you 5 as a factor, and we're going to divide. So that we do that with synthetic division. So step 1, synthetic division. So synthetic division. Here we come. And so you grab the 3 they gave you, and you put it right out there. And then you grab the coefficients, like the 9, and the minus 33, 1, and the minus 9, right? Remember how synthetic division works? You bring down the first number. We call it synthetic because it's false. Like synthetic fabric is not, it's fake. It's artificially made. So this is artificial division, meaning we don't have all the x's and stuff in there. We just have the numbers. It's just a shortcut, quick way to do it. So how we go 3 times 9 is 27, and then we add these together, this and this, right? Minus 33 plus 27. Is that minus 6? Yeah. And then the 3 does that one. 3 times minus 6, multiply, minus 18. And then we add this and this together. And what's that? 21 minus 18 gets a 3. And then we do it again. 3 times 3 is 9. And we add these together. Minus 9 and 9 is 0. Remainder, no surprise. We knew we get zero remainder because that just means 3 really goes in. Just like we got a zero remainder when we divide it by 5. Okay, so now we take the answer we got, and this is going to be with an x squared minus 6x plus 3. Why? Why did I start at x squared? Well, because we divided it. Whenever you divide something, you get smaller. Like we took the 30, we divide by 5, and you get 6, you get something smaller. So we took the x cubed, even though we were just writing the numbers, it was really x cubed. And this was x squared, on down you go. And we divided it. So the answer we get is got to be smaller. So 1 degree lower. So if you start with x cubed and you divide, you get down to x squared. So now we've got this remain. This is like our 6. This is what we get, the other quotient after we divided by 5. And so now it's time for step 2. And that is we do the quadratic formula on our 9x squared minus 6x plus 3. We identify our A, our B, and our C. So you remember the quad? I'm thinking. It's in the notes. All this is right up here in the notes. There's the quad right there. Oops, right there is the quad. Got it in the notes. So let's do it. Here we go. So what's the quad? How's it go? Negative b plus or minus the square root of b squared minus 4ac all over 2a. So here we go. So negative b, and what's b? Right there. Negative 6. Plus or minus square root of b squared. Negative 6 squared minus 4 times a times c. Here's a, here's c. Times 9 times 3 all over 2 times a. All right, and so bring it down. Yeah, so this piece of the puzzle right here, that is going to be negative 6, so that's going to be plus 6, right? And then negative 6 squared is 36. And now right here, negative times positive would be negative. And then just multiply that on your calculator. It's at 12 times 9, 90. I think it's 108, unless I'm mistaken. Yeah, 108. Okay, so we've got that. And on the bottom, 18. So now we keep it rolling. And what we got? And this is 6, this is 18. Oh, whoops. 6, 18. So when they're inside, I don't know. So 36 minus 108 minus 72. Okay, so minus 72. Now we got to simplify. Well, first off, what do we do with that negative sign inside a root? It kicks out an I right to the front of the root, doesn't it? So then we've got to simplify the square root of 72. How do we do it? We just break it down. So use your calculator. So 9 times 8, that's 3 times 3. Those can't go down any further. And then 2 times 4, that 2 can't go down any further. And then 2 times 2. So we broke down that 72 as far as it'll go. So the square root of 72 is the, get a little more space there, is the square root of 3 times 3 times 2 times 2 times 2. Okay, now remember what square roots do? They're 2-for-1 deals. So 2 3s inside, sends 1 3 out, gone. 2 2s inside, sends 1 2, and they multiply on the outside just like they're multiplying on the inside. So 3 times 2 is 6, right? 6. And what's left on the inside? Only that leftover 2. 6 root 2. So square root of 72 is 6 root 2. So therefore, this is going to become, it's going to become 6 plus or minus 6i root 2 over 18, right? Because we have the I that already was outside, and then the 6 root 2, it's there also. That's the breakdown of the 72. Okay, now, how do we simplify that? We'll just separate that into two fractions. Just make it 6 over 18 plus or minus 6I root 2 over 18, right? Because that bar goes all the way across. That 18 is underneath both of them. And then you can just simplify these fractions. Just reduce it, divide by 6. Top and bottom, this is 1/3. Plus or minus, same thing here, divide by 6. Top and bottom, that'll just be I root 2 over 3. So in other words, now we've got it. So what are our 3 zeros? The first one they gave us, which was what? 3, just plain old 3. So 3. And then the 2 we just found, 1/3 plus I root 2 over 3 and 1/3 minus I root 2 over 3. I did the plus and the minus options there. Is that what they said? I think they did. 1/3 plus. And they put the I at the back. That's fine. You can put it in the back or the front, whatever. It doesn't matter. It's all the same thing, you know. If you want to put this I back here, that's okay. You can put it in the top. You can put it in the front right here or the right here. It's just multiplied times the root 2. So it doesn't matter. If it's in the front, it's over 1. It's the same thing. So there we go. There's the 3 zeros. Those are the 3 places going back to the original graph. Those are the 3 zeros. Only one of them is actually a 0, a place where it really is real and hits the x-axis really at 3 right there. The other 2 are imaginary because they're not real. It doesn't really hit the x-axis at those other places, right? So we got one real place that hits the x-axis and 2 parts that have imaginary, right? This is an imaginary number. It's complex. A complex number that has imaginary and real parts, but it's not real. It's not completely real. So let's recap. How did we do it? You start with the function they gave you and the x-intercept they gave you. You do synthetic division. You get the result. You put that in the quad. You simplify the quad. Make sure you know how to do all these root breakdowns and all that kind of stuff. And there's our 3 zeros, 2 of them being complex zeros, one of them a real 0. There we go.